Hello and welcome to Trevor's Tutorials. I'm Trevor Slocum. In this tutorial, we'll add some chopstick obstacles to our game. We'll learn how to draw vertically flipped images, how to randomize the placement of the chopsticks on the screen, and how to handle collisions between the player and the chopsticks. The chopstick image we'll use in this game is 16 pixels wide by 152 pixels high, and it's a transparent PNG image. The chopstick is pointing up, and in order for us to draw a chopstick pointing down, we'll need to flip it vertically. To do that, we'll call the scale method of the geometry matrix. We'll provide it with a value of 1 for the x parameter and -1 for the y parameter. When we do that, the image will be flipped across the axis of the origin point. So in this case, the image has been flipped and it's now above the origin point. We'll randomize the placement of the chopsticks on the screen, so we'll need to give each chopstick a X position, a Y position, and a flag that controls whether or not it's flipped vertically. To handle collisions, there's many different ways we could go about it, but for simplicity in this game, we'll create some rectangles for the player and rectangles for the chopsticks. And to handle the collision between the two, we'll just check if the rectangles overlap. So here we have two rectangles for the player. It's not perfect, but it'll work well enough for this game. And here we see the rectangles for the chopsticks. Again, they don't perfectly cover the chopsticks, but they'll work well enough. So let's take a look at the code. Because this tutorial builds on the last one, we'll just take a look at what's new here. We've added a chopstick.go file where we define a chopstick gap, which is the minimum distance between the end of a chopstick and the top or bottom edge of the screen. We define a new chopstick type, which is a struct with 3 fields, x and y, which are integers, and flip, which is a boolean. We define a randomize y method, which sets the y position to a random value respecting the gap that we defined earlier. We also define a collision rect method, which returns the collision rectangle that we saw earlier. In game.go, we now define a rectCollide function, which returns true when the two provided rectangles are overlapping. We've added a chopstick image field to our game, and we define a chopsticks slice, which could be any number of pointers to chopstick structs. In reset, we clear out the chopsticks. This simply resets the slice while keeping the memory that's being used to hold it instead of releasing that memory back to the system. So when we go to add more chopsticks into this slice, they'll just use that memory that's already been allocated for it. We'll set a default flip value based on a random number, which is either 0 or 1. If it's 0, the first chopstick on the screen will be flipped. And whatever that default flip value is, the next chopstick on the screen will alternate that flip value. And here we create 4 chopsticks, setting their X position to the screen width divided by 4, multiplied by the current iteration number. And that starts at 0. And what that means is the 4 chopsticks will start from the left edge of the screen, and they'll be spaced apart by a quarter of the screen width. And to that we add 42, just to give the player a little bit more of a gap before that first chopstick comes up. And here we set the flip value based on that default flip variable that we set earlier. And we compare that with I modulo 2, or whatever the value of I divided by 2, whatever the remainder is of that. And for each of the 4 chopsticks that we create, we'll randomize the Y position. In Initialize, we load the chopstick image. And here we define the player collision rectangles. In Update, on the first tick of the game and every third tick thereafter, we'll move the chopsticks across the screen to the left by 1 unit. If the X position of the chopstick is -16, or in other words, it's now completely off of the left edge of the screen, we're no longer able to see it, we'll reposition it to the right edge of the screen and randomize its Y position again. And here we check for the collision between the player rectangles, both of them, and the 4 chopsticks. If we do find that either of the player rectangles collide with the chopstick, we reset the game state. Here we draw the chopsticks, and as we saw earlier, we flip the geometry matrix vertically by providing it with a Y parameter of -1. And that's it. Let's take a look. And there is our updated game with chopstick obstacles. In the next tutorial, we'll learn how to draw text on the screen so we can show the player's current score. See you there.